Okay, good morning. Okay, good morning. Hopefully, everybody is ready to study. Okay, hold on. Just waiting for the Zoom to start. Okay, all of y'all can see the screen right over there. For those who are in YouTube, you can say good morning so I can know that you are there. Okay. Okay, good morning, Roberto. Good morning, Angelia. Good morning, Karanta. Amy, yeah. Okay. Now, I hope everybody is ready to study. Soon we will start live. Okay. I'm going to share. Share. So all of y'all can see the screen already. Okay, those who are on YouTube also you can see the screen right now. We are going to study inverse function today. More on that. So hopefully everybody ready lah. Okay, Chu, good morning. Hopefully that you all realize your mistake yesterday and you all will perform better today. Okay, I'm good, Shakir. No problem. Okay, but yep, hopefully you all are doing well also. Okay, soon I will start. So hopefully everybody can be ready. At Zoom, can all of you all hear me? Clear? If yes, I hope to get some response. So I know all of you all are ready to study. Clear? Okay, good then. Okay, on YouTube, hopefully everybody is ready to study. Still waiting for you all to join, waiting for your friends to join. So yeah. Okay, I'm still waiting for some response from all of y'all. So yeah. Okay, sharp 10 o'clock I will start. So hopefully everybody is ready lah. Okay. Meanwhile, y'all can enjoy this small short music. Okay, hopefully everybody is ready and going to start soon lah. In 3 minutes we will start. Okay, I hope that you all realize that uh, the quiz yesterday. From there, you all should know that a lot some more which you all do not know. So need to learn more lah. Wow. I know lah, you finished class already. Ke accounts dah habis dah. Boleh balik dah. Accounts dah habis dah. Boleh balik. Okay, so in a while I start. Hopefully everybody is ready. I can see many of you all joining. So good morning, everyone. Good morning, Marcel, Atika, Rafiq. Good morning, Hang. Good morning, Hang. Hang Jin En. Congratulations. Yesterday you managed to get 25 ringgit, right? If I'm mistaken, it's yours, right? Jaswin, good morning. Siti, good morning. Okay, hopefully you can keep it up. Not Hang, sorry, yeah. It was Chong Gin Kai. Yeah. Okay, Stephanus, good morning. Excellent, good morning. Okay, they are 17:48, so around few people already joined, so I'm just going to start in a while. Hopefully everybody ready lah, eh? Okay, hopefully everybody ready and we can begin soon lah. Okay, we can begin soon. Those in YouTube, are you all ready? And those in Zoom, are you all there? Are you all okay? Can we begin? I think I can begin now, eh? Okay, so I will begin the class right now. Let's start lah. Okay, now first thing I would like to say that please realize that next week is your UPS 2, okay, which is going to be chapter 5 and also chapter 4. So from what you studied and whatever you scored yesterday for your quiz, reflect on how much you know lah. Okay, so today I also did prepare a small quiz for you all. Hopefully that you all can do that quiz nicely and in a better way to improve your understanding a little bit and to prepare yourself more lah. Okay, to prepare yourself more. I will send the quiz questions and what is this called? The answers by Monday to all of y'all after you have done during the weekend. Okay, after you have done during the weekend. So please do up the quiz lah. Okay, for those who are in the Google Classroom. Okay, now that's for sure. That's for everybody on Google Classroom. Okay. Okay, now we move on here. The next topic here, what we need to know is how to find the inverse function. Okay, how to find the inverse function. So if you really look over here, the next thing we want to learn how to find inverse function. And we understand the inverse function that f is x goes to y, and then f inverse is y goes back to x. And if you look over here, the relationship, the domain of f is actually the range of the f there, or the inverse over there. Okay, the range of the inverse. Okay, and the range of inverse or the range of f is going to be the domain of f inverse. Look over here, I think it's better to see here. Okay, the domain of fx is the range of f inverse, and the range of fx is the domain of f inverse over there. So that is something which you all should know lah. Okay, that is something which we should know. And this is the reason because we reflect the graph on y equals to x. We always reflect the graph on y equals to x. So if this was a fx function, I'm very sure the inverse will be like this lah. Okay, so you can see that the range value over here came over here. Understand? Came over here, and the domain value. Okay, the domain value which is from here to here. Maybe I put in pink color. From here to here, came up here now. So that is the domain value. Understand? So it's just a reflection of the y equals to x-axis. That's why if anyone asks you why is that the case, because it reflects on y equals to x lah. Okay, then we carry on some more. Okay, here so you can see it's a reflection on y equals to x over there. Okay, now how to find inverse? Now to find inverse, of course you can use this one method, y over 1 minus x, then y 1 minus x equals to 1, and then from here you make x your subject. Okay, so 1 minus 1 over x equals to y there, or let's make it a bit more slower. Okay, this is what you all study in Form 5, yes sir? So f inverse x is 1 minus 1 over x, which is x minus 1 over x. X cannot equals to 0. Now, This is for 1 over 1 minus x, not 1 over x, 1 minus x plus 2. Okay. Now, instead of using this, we also can use the formula of f inverse x equals to x. Now, this one you all should understand this line. This is very, very interesting. Okay, f inverse x equals to x. So f inverse a also equals to a, and f inverse fx also equals to x. So f inverse f a plus a square plus 1. This one also must equals to a square plus 1. Because of the formula there. So actually the f inverse is supposed to be found with that formula lah. Okay, so how can we find using that formula? Okay, how we can use that formula to find? Here 1 over 1 minus f inverse x, okay, plus 2 equals to x. We have to make f inverse x our subject. So 1 over 1 minus f inverse x equals to x minus 2 over 1. I can terbalikkan this fraction. So 1 minus f inverse x equals to 1 over x minus 2. You can shift 1 minus 1 over x minus 2 equals to f inverse x. So from here, you can tell me x minus 2 minus 1 over x minus 2 equals to f inverse x. X minus 3 over x minus 2 equals to f inverse x, such that x cannot equals to 2. Why x cannot equals to 2? Because the denominator cannot take 2 lah. Okay, now since the denominator cannot take 2, we know this already. So now from here, we can see very clearly that the domain of this is going to be 0 to 2 or negative infinity to 2. Okay, then union 2 to infinity. This is the domain of f inverse. And this is going to be the range of your fx lah. Okay, this will become range of fx. Understand? And the domain over here is very clearly stated, x is cannot equals to 1. So all the real value for fx here, the domain of fx is going to be all real value except 1. And this is going to be the same as range of f inverse x. That is going to be the range of f inverse x. You don't believe? You can see from last time we learned already, right? 1, 1. So 1 over 1, the y cannot equals to 1, right? Not? So since y cannot equals to 1, the range cannot equals to 1. Lah. So the range of f inverse. Understand this or not? Clear until that? So the domain will become the range will become the domain. Clear until there, everybody? Any problem? Understand? Hello class, understand? Okay, I wait for response before I move on. Nobody responding yet, so yeah. Do you all understand class? Are you all there? Clear? Okay, good. Atika say clear. Those in Zoom, are you all okay? Any question? Understood that? Okay, very good. Okay, good. Hang. Okay, good. Chu. Okay, now I move on now. Okay, now I move on. Okay, the next part there, they tell me that the function f and g are defined as fx and gx over there. Okay, okay, Ain. Okay, Hakim. Pay attention more. Now, they say function f and g are defined as fx and gx over there. Find f gx and deduce f inverse x. Okay, no problem lah. So if I just want to do this question by myself instead of looking at the answer there right now, let's see how we can solve this problem lah here. Okay. Okay, I just take this example. We try to do together here. It's not that hard. It's quite easy already. Okay. So from here, you can tell me f gx is going to be f, gx there is going to be 3x plus 5 over 2 minus x. So we know that x cannot equals to 2 over here, and x cannot equals to negative 3 here. Okay, so now I want to find the f gx here, 2. Okay, put inside 3x plus 5 over 2 minus x minus 5 there. Okay, over with 3x plus 5 over 2 minus x there plus 3. So you can tell me this is going to become 6x plus 10 minus 10 plus 5x over 2 minus x. Okay. Over the thing, 3x plus 5 plus 6 minus 3x over 2 minus x. So this and this will cancel off. From there, you can tell me this is 11x over 11 lah, which is just x, I think. Right now, that is just x over there. So yep, we get the answer there. But remember one thing, what is the domain of this function right now? Domain of f gx. Remember, x cannot equals to -3, x cannot equals to 2. So it's all real value except x equals to -3 and x equals to 2. Or you can say all real value and x cannot equals to -3, x cannot equals to 2 lah. Understand, the line there is except lah, the line there is except over there. Okay, so if you want to see in interval form, -infinity to -3 union with -3 to 2, see I put close open interval there, and then union with 2 to infinity. Okay, why -3 and -2 cannot? Because at -2 at 2 gx is not defined, and at -3 fx is not defined, so the value cannot take -3 and 2 over there. So I hope that is clear for everybody lah. Okay, that will be the domain. Of course, the the range. If you look over here, the range here for fx, y cannot equals to 2, and for gx here, y cannot equals to -3. So the range of f gx is just going to be, okay, what is it going to be? Okay, from -infinity to -3, union with -3 to 2, union with 2 to infinity. Okay, that is going to be the range of f gx over there. I hope that is clear. Okay, basically by using your what is this called, graphing method, you will be able to see this lah. Any problem until there so far? Can class? Okay, now we go on little bit. They ask you to deduce the f inverse x. So let's deduce f inverse x. They gave me fx here, 2x minus 5 over x plus 3. Okay, x plus 3. Let's use a different color, okay, to make it more fun. So I know x here cannot equals to -3. So you know that the domain of fx is going to be all real values except -3. Understand? All real values except -3. Or of course you can write lah, -infinity to -3, union with -3 to infinity. Clear? Okay, open interval lah, open interval. Okay, now once I know the domain already, I do not know what is the range. Never mind. But actually you know also lah, 2 over 1, right or not? So what fx is going to be all real values except 2 lah. Okay, because 2 over 1, y cannot equals to 2. Understand? We know here y cannot equals to 2. Okay. Now we're going to find the f inverse. So 2 f inverse x minus 5 over f inverse x plus 3 equals to x. So I get 2 f inverse x minus 5 equals to x f inverse x plus 3x. Let's make f inverse x your subject. Okay, shift this thing here. So I get 3x plus 5 there. Factorize out the f inverse x. So you get 2 minus x equals to 3x plus 5. So from here, f inverse x equals to 3x plus 5 over 2 minus x. And such that x cannot equals to 2 lah. Okay, x cannot equals to 2. So if you look over here, see, x cannot equals to 2 over here is the same as here. You can see that. So the domain over here, the domain of f inverse x is all real values except 2. See, it's exactly the same as this thing here. Am I right? So this part here is exactly the same as here. Just that last time we use fx, now we use x. Okay, and the range of f inverse, okay, the range of f inverse there is going to be f inverse x, okay, can be all element of real except -3. And you don't believe, you see, 3 over -1 is -3. 3 over -1 is -3. So this part here is exactly the same lah. This part here is exactly the same as this part here. Can see that green color part is the same as the green color part. The blue color part highlighted is the same as the blue color part highlighted over there. Any problem until there so far? Any problem until there so far? Okay, if no problem, then I would like to see more questions. Okay, now if you look over here, the next question over here, this part here, they ask f inverse square. So f inverse square here is just f inverse. Okay, f inverse. I hope that is clear for everybody lah. That is just f inverse. So you have to take f inverse twice lah. Once you find the inverse already, you just must take 2 times only. That's all. Clear? Okay. So I hope that is clear for everybody lah. Okay, and you should note also that f inverse square is the same as you take the square first, then you take the inverse. Understand? You take the square first, then only you take the inverse. So I hope until that everybody okay. Okay, the example 4 there is the example, so you all can go through that by yourself. Okay, and this thing here is very important to note lah. Okay, this is very important for us to note that if I give you fg inverse, okay, fg inverse, this means g inverse f inverse x. Okay, this means g inverse f inverse x. That is not the same as f inverse g inverse. Fg inverse is the same as g inverse f inverse x. So note that. Make sure you note that we put g first, then only f inverse. Okay, we put g first, then only f inverse. So I hope that is clear for everybody. Okay. Now, that is done. So I can move on some more. Okay. Now let's look over here. Okay, they say that given that fx equals to x minus 1 square plus 1, plus 2, for x greater or equals to 1, find the f inverse x and state its domain and range. So to find the f inverse, very easy. F inverse x minus 2 square, a minus 1 square plus 2. Okay, must equals to x lah. Because the formula which I'm using is f inverse x equals to x. Because fx is given, so I start with f. If this was f inverse, then I have to start with f inverse lah. Then the formula which I will use will be f inverse fx equals to x. Understand? Any one of these also you can use lah. Okay, depends on what is given to you. Okay, depends on what is given to you over there. Okay, now in this case here, I start with fx because f is given. Okay, so f inverse x minus 1 square plus 2 equals to x. Now from here you get f inverse x minus 1 square equals to x minus 2. So f inverse x equals to square root of x minus 2 plus 1. Now let's just look over here. We know that the minimum point here is 1, 2. This is your minimum point. The x is element of all real, x is just greater or equals to 1. And that is your domain of fx. So I know that automatically this will become the range of f inverse x. Don't believe, later we see. And okay, fx must be greater or equals to 2. So this is your range of fx. I know this will become the domain of f inverse x. You don't believe, later we see here. Now you look over here, you can see that x must be greater or equals to 2. And that is your domain of f inverse x. See, this green color part and this green color part is the same. Okay, greater than 2. And then over here, we know that if I put 2 inside here, 2 minus 2 will become 0. 0 plus 1 is 1. Yes, not? So f inverse x must be greater than or equals to 1. Okay, f inverse x must be greater or equals to inverse what equals to 1 over there. So you can see this blue color part and this blue color part is the same there. Okay, quadratic function. So here is your quadratic function for the red color line. And this is a set function. So the set function will go somewhere like this lah. Am I right? But since they want more or greater than 2 only, so here lah, this part only exists. And here also only this part exists. So you can either draw the fx and then get the f inverse, or you can even draw the f inverse and then get the fx. Up to you lah. Depends on which way you like. Okay. So here we got few exercise over here for you to attempt and understand this question. The most important thing, okay, you must know that the domain of fx is the range of f inverse, and the range of fx is the domain of f inverse. Second, you also should know that f inverse x equals to x, that is the formula for inverse. And the third thing you should know that f gx inverse is the same as g inverse f inverse x. Okay, so I hope this is clear for everybody. Any problem until here so far? If everybody clear and no question, then I want to move on. If you got question, please do ask. Okay, if you got question, please do ask. I wait. If no, then I move on. Okay, I move on now. Okay, now since I move on, the next one is going to be exponential and logarithm function. Now under exponential and logarithm function, it's quite easy actually. It's not that hard. Okay, let's see over here. We can see that under the exponential function over here, f inverse x equals to log ax. Okay, so if let's say I give you a power of x equals to fx, now I want to find f inverse, this will become a f inverse x equals to x, based on the formula that f inverse x equals to x. So f inverse x is actually just log ax. And if I give you fx equals to log ax, so f inverse x will become log a f inverse x. So f inverse x is just a power of x. So you can see both of them are inverse of each other lah. Both of them are inverse of each other. Logarithm is the inverse of exponential. Exponential is the inverse of logarithm. Okay, but one thing you must understand for logarithm, that any log ax, here the x must always be greater or equals to 0. Must be greater than 0. Sorry, not greater or equals to, must be greater than 0. So the domain must always be greater than 0 lah. The domain here must be always greater than 0. So if I give you ln x plus 1, you know that x plus 1 must be greater than 0, x must be greater than negative 1. So x equals to negative 1 is called the asymptote. Okay, it's called the asymptote, means x cannot equals to negative 1 over there. Understand? X cannot equals to negative 1 over there. Can understand until there, everybody? Okay, so negative 1 for logarithm function. Yeah, let me see. Yeah, yes, correct. X cannot equals to negative 1 over there. It can be 0, but it cannot equals to negative 1. I hope that is clear lah for everybody. Any problem until there so far, class? Can? Can ah? Hello? Can or cannot? No response. I need to get some response so I know. Okay, when you shall say can. Which part you don't understand, Jinson? Can I know? Can you speak up? The speaker is working, no problem. Jinson, speak.
So I don't understand for the part where you say the inverse of log is the thing.
Oh, okay. You look over here. This is exponential function, yes or not? A power of x, right? A power of x, the inverse you get log, yes or not? Am I right? Okay, or log or ln lah, doesn't matter. Log or ln is the same, right? It's just the base only there. Okay, so and log, the inverse you get exponential one. A power of x. A power of x is exponential one. So exponential and logarithm are inverse of each other lah. If your fx is a logarithm function, then the inverse will definitely be an exponential function. And if your fx is an exponential function, the inverse definitely will be logarithm function. Clear with that now? Okay, Jin.
Okay.
Understand?
Okay.
Means
Okay,
they are
thank
inverse
you.
of each other lah. Okay, like basically quadratic function, the inverse of a quadratic always will be a square root function, yes or not? And the inverse of a square root, you don't believe, you can go and try, it will be a quadratic function lah. Understand? It will be a quadratic function. Just to stress a little bit more inside that. Okay, let's say if I give you ln x plus 1, I know one thing, that this inverse is going to be exponential function. So ln f inverse x plus 1 equals to x. So f inverse x plus 1 equals to e power of x. f inverse x equals to e power of x minus 1. See, exponential function. And if I give you fx equals to e power of x plus 1, okay, uh, well, let's just give like this, e power of x minus 1. So I know that e f inverse x minus 1 equals to x. E f inverse x equals to x plus 1. F inverse x equals to ln x plus 1. So see, exponential became ln, ln became exponential. Simple as that. Okay, I hope that is clear right now. More clearer than whatever you used to, or whatever you understood now. Can I move on?
Okay, sir.
Okay, let's move on. Now, so again, simple as that. The basic properties of exponential function here. Let's see. The basic properties tells you that exponential function must be greater than 0 if the a is positive lah. Okay, a is positive, the x also is positive, so it have to be greater than 0. Okay, you don't believe, you can type your calculator, you can press in your calculator and you can plot. So there are two ways over here. If let's say this is 1 over 2 power of x, then when x becomes a very big number, this approaches 0 over there. 1 over 2 approaches 0. So if 1 over 2 power of 1000 is nearly 0, yes or no? Okay, so we know that this one will be here. Okay, in this case here, this actually is here, right? 1 over 2 power of x. If this case here, 2 power of x, when x is 1000, is infinity one. It's a very big number. So will be here. And 2 power of 0, which is 1. And then definitely 2 power of negative 100 is going to be a very, very small number, which is here. So that's why the graph becomes like this. Okay, that's why the graph here is like this. But if let's say I tell you 1 over 2 power of x, if x becomes 100, then will become 0, nearly 0. X becomes negative 100, then it's different already, because 1 over 2 power of negative 100, this is going to become 2 power of negative 1 times with negative 100, which is 2 power of 100, which is a very big number. So up here lah. So that's why here is this way, the graph. 2 power of 1, half power of 0 is also 1. 2 power of 0 also is 1. So that's why you can see the graph that way. Okay. Now, if we look over here, e power of negative x, the negative x is here. Why this negative x actually is just a reflection on the x-axis. Sorry, on the y-axis. My mistake. On the y-axis. Okay. The negative x there is a reflection on the y-axis there. Okay, but if let's say here I give you fx equals to negative e power of x, this negative is reflection, here got right, sorry. This negative is reflection on the x-axis. See the difference over there. One is reflection on the y-axis, one more is reflection on the x-axis. Okay, so here we got reflect on the x-axis first, then we also got reflect on the y-axis. So if the original graph is like this. So reflect on the x-axis, we get like this. Then you reflect on the y-axis, and that's where you get this purple color graph. Understand? So first is reflect on the x-axis, then reflect on the y-axis. I hope that is clear lah. Okay. And then this plus 1 is move the graph up by 1. But if move graph up 1 by 1, I told you already, the plus 1 there is move x-axis down by 1. Negative 1, move graph down by 1. Okay, so this negative 1 here, move x-axis up by 1. It's opposite line. You move the graph, you follow. But if you move the x-axis, you reduce. You go opposite direction lah. Plus will go down, minus will go up. Okay, but then if let's say it was like this, e power of x plus 2. This plus 2 over here, move y-axis to the right. And this negative 1 over here, move y-axis to the left. Y-axis we follow, negative we follow, we move to the left, +2 move to the right. So I hope that is clear for everybody lah. Any problem until then so far? Class? Can or not, class, so far? Hopefully you all okay. If no response, I do not know how to proceed. Yeah, okay, can okay, hopefully everybody okay lah. Okay, so understand the thing lah. Okay, how about this 2 here? 2 here got actually nothing. This is just expand the graph. Okay, so if let's say your graph was like this, now when got e power of 2x, the graph will become like this lah. It becomes a bit more higher, right? Not, it will become more higher, or maybe the original graph is like this, it will become more higher. You expand the graph, so this is e power of 2x. Okay, e power of 2x here. Just see how I can sketch here like this. This is e power of 2x, this is e power of x, but it still cuts at the same y point, which is 1. It still cuts at the same y point, which is 1 over there. Understand that is just expansion of the graph over there. Okay, so I hope that is clear for everybody lah. Okay, of course, negative 2x means reflect on the y-axis lah. Negative 1 here means move to the left for the y. Understand? Move to the left for the y there. Okay. Same goes with the logarithm function over here. Okay, under logarithm function, this is the basic graph here. Okay, so if I give you b, okay, which is less than 1 or 0 and 1, then it will be here lah, this way, in the opposite direction. It will be this way. Clear? So it's just in the opposite direction there. Okay, you still can plot, no problem. You can press your calculator. Log 2 is going to give you a positive number, so of course up here. Okay, of course up here. And log negative 1 and 1, log half will going to give you a negative number, which is here. Okay, but remember, log of negative does not exist. So here we'll never have a graph lah. Will not have a graph here. Okay, now if I give you ln x, it's like this. Negative ln x, this means reflect on which axis? Anybody can tell? Reflect on negative ln x. Reflect on x or y? Okay, I wait. This one reflect on? Come on, class. Yeah, x-axis. That's right. Reflect on x-axis. Okay, you reflect on x-axis. Okay. And then if ln negative x reflect on? Yes, reflect on. Next one here. That's right, Ain. That's right, Hang. So you reflect on x-axis for the first one there, b. And then the next one there, reflect on? Yes, y-axis. That's right. Vanisha, Siti, Sarah, correct just now. Okay, y-axis. Then here we got negative ln x, negative x. So this negative x, this negative is y lah. Okay, I hope that is clear lah. Okay, can understand? Okay, now let's look over here. Ln x minus 1. If ln x minus 1, x minus 1 must be greater than 0. So x must be greater than 1. This x greater than 1 is your asymptote right now. Okay, why x minus 1 must be greater than 0? Because we know that ln cannot take a negative number. So this will become your asymptote. Now if you look over here for exponential, the asymptote was 1 over here. Why? Because we know if I put 0 inside here, okay, 1 minus e power of 1. So 1 minus 1 over e, which is 1, nearly 1 there. It will not be able to touch 1. Understand? It will not be able to touch 1. Clear? So y equals to 1 is your asymptote here. And if I look at this original graph here, I know that y cannot be 0, right? Not so y equals to 0 was my asymptote. Understand? Y equals to 0 was my asymptote here. Okay? So I hope that one you understand now. Okay. Now we go on some more. Let's see negative ln x plus 2. So we know x plus 2 must be greater than 0. X must be greater than negative 2. So if x is greater than negative 2, this is the domain. Okay. So this will become the range of f inverse x. This will become the range of f inverse x. So x must be greater than negative 2. It cannot be less than negative 2. Okay. So if let's say for logarithm, this is a logarithm function. So for exponential function, I know this is your negative 2 here. Okay, the value of that. So of course your graph will be either be like this, will be like this lah, because negative ln x plus 2 there. So if I reflect here, okay, reflect here, this negative 2 will become here now. Okay, can see the purple color one. And then this point here will come here. Let me just reflect nicely. So here will go up further, here will come nearer. Here, something like this, right now. Okay, so I think the reflection, my reflection, my drawing is not that good, lah. Okay, hold on. Let me reflect nicely so can see clearer. This will be nearer to here, this will be further away, so here. So something like this. Okay, no. It must cross here. Yeah, something like this. So your graph will be something like this here. That is your reflection graph. Can see that? Okay, I hope everybody can see this line, the reflection graph there. Okay, you reflect on y equals to x over there. Okay. So here also the same thing. This negative 1 here. Okay, sorry. Plus 1 here. This 1 here is move the y-axis by 1 to the right. Okay, and minus 1 here, move the y-axis to the left. Okay, so this is how basically you see this lah. Okay, of course you have to try and draw all this graph lah. So if you can draw this graph, that is very good already lah. Okay, so here we got few questions. I expect you to draw the graph and show me back again. Of course, you might tell me, sir, I plot by using the table method and then I draw. Can or not? Can, no problem. Okay, some of y'all want to use the table method and plot, means you plot roughly, sketch first, and then you draw. Can, no problem. Clear? I tried to help you for one first, 2x plus 1 here. So I know that this graph is going to be like this, the original 2 power of x. Then plus 1 means this x-axis must go down. So now your x-axis here will become dotted here. And this will become your asymptote 1. And here will become your x-axis 0. You can see that? Okay, the x-axis moved down 1 already. And that's it. You get your graph already. So you know your domain is more than 1. Your range is more than 1. Your domain is all real values of x. Understand? You know the domain is all real value of x. This y here is typo, so ignore the y there. Clear? But if it was half x minus 1 then, so if half x minus 1, I know the graph is like this originally. Okay, originally. But minus 1 means the x-axis must go up. So here was 0. Here if x was 0, was 1 here. Just now was 1. So minus 1. Now the graph will come here, the x-axis. Okay, here will be your dotted line. And here will be negative 1. Here will be 0. So you know your range is going to be anything above negative 1. You know your range is going to be anything above negative 1. Okay, so I hope that is clear lah for you. Okay, now for me to sketch the what is this called, the inverse, draw the blue color line here. You know negative 1 is here, so negative 1 will be here, somewhere here, and the graph will become something like this. Okay, something like this. So it's a reflection lah. Okay, it's a reflection of y equals to x over there. So I hope that is correct and you all can understand this lah. Okay, now we go on some more. Okay, now this next part here, they tell you to find g of x and f g x of exponential function. and logarithm function. So that's quite easy. Same method like just now. Okay, let's say they want to find g of x. G fx is just 2x plus 1. So e power of 2x plus 1. Then need to sketch this graph. So e power of 2x, e power of 2x is like this. Plus 1 over here. That plus 1 is not movement of the x-axis. It's actually the movement of the y-axis. The plus 1 there is the movement of the y-axis. So you know that originally this is 0, means 1 here, because it's for e power of 2x. So if plus 1 means move the y-axis to the right. So if you move the right y-axis to the right, your y-axis will come here, and this value will be more than e power of 2x plus e power of 1 lah. So this will become e power of 1 there. Understand? So that's fine. So this will be your dotted line. The purple color line there will become the dotted line. That's all. Can you understand that? Okay, now originally here was 0. So now here became 0. Here will become negative 1 lah. That side will become negative 1 over there. Is it negative 1 or negative half? Let me just see. Negative half. Okay, negative half. Why? Because negative half times 2 will give you negative 1, plus 1 will give you 0. So that side will become negative half. I hope that is clear for everybody. Okay. Okay. Then I move on some more. Let's say 2 power of e power of 2x plus 1. So 2 power of e power of 2x. This part here is 2 power of e power of 2x plus 1. Let's draw this graph here. I know that this is 2 power of e power of 2x there. Plus 1 there means move the x-axis down by 1. So here will become 1. Here will become 0. And this 1 there will become dotted line lah. So this will become dotted line here. Now at 0 there, that becomes 3. So the value here is 3. That's how basically you get the graph lah. Okay. Of course, it will come by practicing lah. Of course, it will come by practicing. Now the next one there, they ask you to find fg inverse x and g inverse fx. So if you look at fx there, they give you ln x minus 2. You can go and find the inverse. Or you don't need to find the inverse in this case. You need to find the g inverse. So 2g inverse x plus 3 equals to x. G inverse x equals to x minus 3 over 2. So now from there, f x minus 3 over 2, which is just ln x minus 3 over 2 minus 2. So you get x minus 3 minus 4 over 2 ln. So here you get ln x minus 7 over 2. Understand? Simple as that lah. That is just composite function over there. So after that, you have to sketch the graph lah. So I hope no problem with that lah. Okay. So to get the x minus 7 over 2 must be greater than 0. X must be greater than 7. So we know the asymptote is at 7. We mark 7. Then they tell me to sketch a ln graph. Okay. So I know the ln graph is going to be something like this. Here, when x becomes 0. When y becomes 0. When y becomes 0 means ln x minus 7 over 2 equals to 0. So x minus 7 over 2 equals to 1 because e power of 0 is 1. So here I get x equals to 9. So I mark here 9. That's it, done. So you know the domain is going to be anything more than 7. Okay, anything more than 7. The range is all real values lah. All real values. For any y value here you can take. Any y value you can take over there. So here, if I want to see, the domain is definitely x minus 2 more than 0, x greater than 2. So the domain is x greater than 2 here. The half there is just making the graph become thinner lah. Okay, we will say thinner. So here, okay, and then minus 3 over 2 means move the x-axis down. Move the x-axis up by 3 over 2. So let's say your original x-axis was here. You move up lah. 1, 2, 3. I mean 3 over 2. Sorry. You move up by 3 over 2 lah. That's all. Clear? So that's how you get the x-axis over there. Okay. Okay. And then I think besides that, not much a problem. It's nearly the same. Okay. Now to show that this is a 1-to-1 function. So 5 plus 5 plus 2e power of negative 2x Okay, if I want to show that this is a one-to-one function, I let this become a, and then 5 plus 2e power of negative 2b. The 5 and 5 can cancel, the 2 and 2 can divide. So e power of negative 2a equals to e power of negative 2b. Take log both sides. So here you get negative 2a is negative 2b, a equals to b. Therefore, it's a one-to-one function already. Therefore, it is a one-to-one function already. So I hope until there I can lah. Okay, so no problem. Besides that, I think it's okay. So yeah, that's all. Now I gave you all this, so I really hope that you all can start drawing, and you already finished drawing halfway. Can prove is one-to-one function, can find inverse, and also can complete the graph lah. Okay, and if let's say you draw and you have any problem or any doubt, okay, on your graph, show me lah in the Telegram group. I will check for you, no problem. Okay, I will check for you. So I'm going to send this whole document, the discussion, to your Telegram group. Okay, let me just send this to your Telegram group. I have around 15 minutes. I just want to see about yesterday's question there. Or maybe after this I send live. Okay, don't worry. I will send to you all straight away. Let's just look at the question which you all saw yesterday. Okay, this question here. So what was so hard about the question that you all did not manage to score very well? Lah? Okay, let's just see that. Okay, this is 1 hour challenge one. So find A. A is a singular matrix. So if singular matrix, what become? What is defined as a singular matrix? I told you all last time in lecture. Singular matrix means determinant must equals to anybody? Yes.
Zero.
Singular matrix means determinant must equals to 0. Yes lah. Okay, remember singular matrix determinant must equals to 0. All of you all know how to find determinant, right? So this should be easy lah. Okay. Next one here, given this matrix times with R transpose equals to 1524. So negative 24. Okay, 1, 5, negative 24. Now how to find this R transpose here? So how to find basically this R transpose here? Actually, you can go and calculate. This is R, yes or not? Whatever here is given is R. So the transpose over here, this will be 3, negative 5. This will be 3, negative 5. This will be negative 3, 5. And this will be negative 3, 5. This is your R transpose right now. So this is what you're supposed to substitute inside. So if you go and calculate this, 2, 1, 0, negative 1, negative 3, 3. And you go and calculate with 3, negative 5. Calculate, see, do I get 1 or not? So if you calculate this, 6, this cannot times at all, yes or not? Because this is a 3 by 3 rows, 2 columns, 3 by 2. So this must be 2 by 3. So which one is 2 by 3 over there? There's a problem in this question, is it? Let me just see. Two by 3. So yeah, I think there's a problem in this particular question here. So maybe that's the reason. Okay, but anyway, I will look into it again. Okay, we will look into this again. We will see. Is there a problem, class? Yeah. Okay, we will see number 2. Okay, we will see number 2 again. Then if A is a square matrix of order 2 with a value of determinant 3, so 2A square there. So that's very obvious, right? Okay, you can straight away get the answer over there. 9 times 2 there. Okay. And then if matrix A and B are square matrix of order 3, which each have a value of determinant negative 2 and 4, find the determinant of AB transpose. AB transpose and AB matrix, what determinant is the same? Okay, is the same over there. So you can time straight away and get the answer. Okay, which of the following statement is true there? Multiply two matrices that are inverse of each other will get an identity matrix. multiply two matrices that are inverse of each other. Yes, correct. This one you will definitely get the identity matrix there. Identity matrix is always a square matrix. That also is correct. For inverse matrix to exist, then the determinant of the matrix must not be 0. That is correct also. If the product of two matrices is a square matrix, then the two matrices are square matrix. That also is correct. So all the above lah. That should be the answer there. Clear? Okay. Let's see the next one there. Given the order A, B, C, D, E. Okay, so which of the following matrix is product is not defined? So if you look over here, A there is 1, 3. Then D there is 3, 2. Okay, so here I get 1, 2 first. Now C there is going to become 2, 2. So this is defined. BAD there, 3, 1, then 1, 3. So you get 3, 3 here. Yes or not? Then 3, 3 already. D there is 3, 2. So okay, define also, no problem, because you get 3, 2 here. The number here must be the same. Next one there, B. B there is going to be 3, 1. A there is 1, 3. So here you get 3, 3. And then E there is 3, 3. Also define lah, no problem. So I think your answer should be D here. Let's check. D 3, 3. B there is 3, 1. You get 3, 1 here. And then D there is 3, 2. See, number not the same, so not defined. D lah. Am I right? Need to be 2 by 1. Which one needs to be 2 by 1? Over there. This one is it? Just now is it? 2 by 1. Why? 3 times 2. Oh, yes, yes, yes. Correct. Can be anything 2 by 1. Yeah, can be anything 2 by 1 here. So if this is 2 by 1, here must be 1 by 2. Yes or not? The row and column must change, right? So must be 1 by 2. So 1 by 2. I think 3 negative 5 can, lah. Right? 3 negative 5 can, and negative 3 5. That is the only possibility for R there. So 2 times 3 is 6. 1 times no, 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 no. Wait. If 2 by 1 here, so here must be 1 by 2. So if 1 by 2 here will be negative 3, sorry, negative 3, 5. Yes, or 3, negative 5. Yeah, now can lah. So 2 times negative 3 is negative 6 plus 5 there, which you get negative 1. So this cannot. So of course this is the answer lah. 2 times 3 is 6 minus 5. So that's why the answer here is 3, negative 5A lah. Clear until there?
So I have a question.
Yeah, see?
Is there any other method instead of try and error for this question?
No, this is not try and error. You will really look over here. This is not a try and error method. This is R. All these are R. Okay? So you want to find R transpose. You know the R transpose have to be 3 by 2 times 2 by 1. You know the R transpose is 2 by 1. So the R must be 1 by 2 lah, because the row and column will change. Remember that?
Oh, yes.
So the R now must be 1 by 2. So which one here is 1 by 2? Oh, 1 by 2 here is going to be this and this. Yes or not? B and D. Yes or not?
Yes.
So now you substitute the B and D here lah. So 3, negative 5. There is no other other method besides trying an error for B and D here lah. So if you're asking
okay.
that here I must try an error, yes, you have to lah. Clear? Okay. Okay. So I hope that is clear. I answered that. Then number 7 there. Which of the following is not the cofactor element? I think this is quite easy. You have to find the cofactor of each and every one. Yes, sir. Okay. And if you know here, this is 4. So 1 plus 3. Yes, sir. Okay. 1 plus 3 there, which is 4 there. So DEGH. So DEGH is here. I think if I cancel, should be here lah. So it's here lah for this C here. Yes, sir. So go and see. This is going to be A1 plus 3. First row, third column, what? So 1 plus 3, right? And then this is 2, 2. And then this is going to be 3 plus 1. Third row, first column, 3 plus 1. And then this is going to be 3, 3. 3 plus 3. Third row, third column. Clear until that? Okay. Okay, let's move on. Yes, Sri, you can use system of linear equation. You can, of course, use system of linear equation, x and y there, and then you get the answer. Yep, correct. If you want to put like this lah, 0, -1, -3, 3, then you're going to put x, y, and then you get the answer here. Then you find the x and y, right? So 2x plus y equals to 1. 0 minus y equals to 5. So y equals to -5. Can, no problem. Okay, you can use that way also. Yep, correct. Okay, I agree. I won't deny. Can, very good. Okay, so Jinswan, I hope you managed to see how we use linear equation. We can use linear equation also for number 2. Okay, can everybody? Okay, hopefully lah. Okay, let's see the next question here. Number 8 here, they ask determinant of A is 6. So if this is the A, determinant of A, find the cofactor matrix for A. Okay, so this is inverse already. You know the determinant is 6 over there. So you can times everything by 1 over 6, right? You can times everything by 1 over 6 to get the adjoint method, adjoint matrix, and then you can straight away get the inverse mark. Okay, you can times, because you times everything by, sorry, you times everything by 6, not 1 over 6. You times everything by 6, and then you get a joint matrix, and then you get the cofactor lah, because transpose the thing to get the cofactor. You transpose the whole thing to get the cofactor. Normally we transpose, then we take 1 over 6 times by the transpose, yes or not? Or times by the adjoint. Right now, we have to times by 6 first lah. So once I times by 6 already, then I transpose the thing lah. Times by 6 first, then transpose. If you times by 6 here, you get 4. You can see 4, -1, -2, -2, 5, -2, 2, -2, 2. Now when you transpose this thing, will become 4, -1, -2, -2, 5, -2, 2, -2, 2. That's it, done. So I think this is the answer. Yep, A should be clear. Okay, so besides that, you all can try minor. I think that's quite easy. Which of the following is not a property of determinant? The value of determinant changes if both row and column are interchanged. Not true. The value of determinant changes if any two rows or column are interchanged. Not true. The value of determinant is 0 if any two rows or columns are identical. The value of determinant gets multiplied by k if all elements of a row or column is multiplied by scalar k. This also is not. This is not true. This is not a property. Okay, this is a property. This is a property. So D there is not a property. Okay. Two matrices A and B are equal if and only if both are rectangular. Both have same order. Both number of columns A in number of columns B. Both have same order and corresponding entries are D lah. Yeah. Say.
For question number 10, the answer they gave is A.
The answer they gave is A. Wait, let me just see. Did I read anything wrong? The value of determinant changes if both row. Oh, wait. Sorry. They say changes. My mistake here. Changes. No, the value of determinant does not change. If you interchange the row and column, it does not interchange. It does not change the value of determinant. Okay, my mistake. Okay, so this is definitely not the property. Okay, the value of determinant gets multiplied by k if all element of row or column is multiplied. Or, okay, they use the word or. Means either one. Okay, means either one. If you multiply the row by k, yes. If you multiply the column by k, also yes. Okay, but if you use the word and, then wrong line. You cannot multiply both row and column. You cannot multiply both. Or yes, correct. Okay, so this is the tricks line in objective questions here. Okay, this is quite easy lah. This one I need to explain, right? Okay, K inverse. Which of the following is true about Kx? Kx is always positive in its domain. In its domain, yes lah, x must be greater than 0. So yes lah, domain. Kx is defined at x equals to 1 over 2. Yes, correct. Kx is a 1-to-1 function. Yes, it's a reciprocal function. And Kx equals to 2 over x minus 2. I don't think so. That is true, right? No, right? Can I just confirm that? Let me just see. Kx is defined at x equals to half. X equals to half. Yes, it's defined. No problem. Kx is always positive in its domain. That is correct. Is this a one? Oh, wait. Yeah, they asked for kx. I have to find first. This is k inverse. Ayo. Okay. My mistake. So if you want to find kx, you have to find y equals to 2 over x plus 2, x plus 2 equals to 2 over y, x equals to 2 over y minus 2. So fx or kx here is 2 over x minus 2. So this is definitely true. Kx is always positive in its domain. X here cannot equals to 0, yes or not? Okay, x cannot equals to 0. So this is not true lah. Okay, it can be negative also, right? Not it can be negative also, because the range over here can be negative or not. The range over here, if you put anything more than 0, range here is always positive, so the domain will be always positive. True. Okay, the domain is always positive. So here kx is defined at x equals to 1 over 2. That also is true, and it's a reciprocal function, so it's a one-to-one function. So all the above lah. Okay, 2 minus 2x over x. So x cannot equals to 0 only. X is still defined at half. Okay. Ah. So over here, this part here is because the range here is always positive. The range is positive. So the domain have to be positive lah. The domain will become positive. That's why. Clear? Okay. Uh, Now domain and inverse, you can go and try back again. Domain here you can see negative x plus 3 must be greater than 0. Negative x is greater than negative 3, x is less than 3. So if x is less than 3, negative infinity to 3 lah. This one and this one. Range of gx. Okay, this is the domain of gx. So this one will become the answer for range. This will be the answer for range already. Okay, negative infinity to 3. And the domain here is going to be 0 to 2. So 2 to infinity, lah, which is, more than 2. What? Have to be more than 2, right? Negative 3. So 3, negative 1, 2. So let me just see. No, this will be negative infinity to 2, if I'm not mistaken. Minus something. 2 minus something. So it must be lesser than 2, lah. That's why D. Okay, hopefully that's clear for everybody lah. If you're not sure, you can go and find the G inverse. If you find the G inverse, fx, okay, minus fx plus 3 square root, okay, minus 2 here equals to x. So you get here 2 minus x, f minus fx plus 3 square root. Bring over 2 minus x square minus 3 negative fx. So here you can see that this is going to be very clearly your value is going to be negative, no wait, 2 3. Okay, 2 3, and this is maximum. So have to be 2 to negative, and negative infinity to 2 lah, D. Clear? Okay, explain number 12. Number 12 here is just writing in linear form. Why? They tell you here the household developer targeted revenue of 60,300. So 350x times with this must equals to this. That's first equation. Total number of house built is 150. So x plus y plus z equals to 150. Okay. And then for every 2 luxury houses built, the housing developer must build an affordable houses. So every 2 luxury houses, okay, double story house terrace and double story detached is classified as luxury house. So x plus y must equals to, for every 2 luxury house built, okay, the housing developer must build an affordable house there. So x plus y must equals to 2z, 2x lah. Every 2, so must be 1. So if x plus y must be as y over 2. So divide 2x plus 2y must equals to y. Yeah lah. Correct, must equals to x over here, if I'm not mistaken. Clear? So from there you shift and you can get the 0 lah. Okay, Izati, hopefully that is quite clear for you. Okay, you can shift and get the 0 there. Okay. Okay. Next one here, all these are function topic. Oh, okay. So maybe that's the reason you all never get to answer lah. Okay. Hopefully now you all can go and do. The questions are interesting. Okay. Tricky, but not that hard lah. Okay, can do still. So if you look over here, which is not possible to match the graph above. If you look over here, this is fx. So this is definitely already reflected on the y-axis already. Okay, it have to be actually negative 2 lah. Okay, but it's reflected already. So 2 minus x here, you know 2 minus x must be greater than 0. Negative x is greater than negative 2, x is less than 2. So this is possible. Here I have to go and test one by one. Okay, have to go and test one by one. 1 there. So when x is 0 is 1. So when x is 0 here, you get ln 2. So wrong already lah. Okay, wrong already. Then if x is 0 here, you get ln 1 is negative. Ln 1 is 0, so negative 1. So this part also wrong. X is 0, you get ln 4. That's wrong. Negative half. Okay, must check again. Sorry. My mistake. X is not 0. X is 1. Ayo, too fast. Okay, x is 1. Ln 2 minus 1 is 1. So ln 1 is going to be 0. So correct. This is possible. 1 here not possible. 1 here also not possible. All this not possible. Only A possible. Okay. Yeah, only A matches. That's right, Kiwi. Only A is the answer. Okay. Why? Because if you look over here, if you put 1 here, 2 minus 1 is 1. So ln 1 is 0. So if ln 1 is 0, so my answer for fx is 0 already. What? So 1, 0 is the coordinate. You can substitute coordinate and get the answer actually. Understand? You don't need to sketch the graph or what. You just need to substitute the coordinate and get the answer. Clear? Okay. Okay. So if you look over here, there. Which of the following pairs exponential inverse of each other? There. Exponential is the inverse of logarithm. So you can see over here, you can find the inverse lah. Find the inverse of exponential here. So this is definitely yes. 3 power of 2x there. Okay, so equals to x, f inverse x here. So I get here log 3x, 2f inverse x, then divide by 2. So this is definitely wrong lah, because you put square root there. Oh, square root can, because power of half can bring up. So can, possible. Okay, this will become half log 3x. Bring up the half will become log 3x square root, correct. Okay, this one here, power of half there. So here you get ln x, f inverse x over 2. Okay, then this 2 will bring up, become 2. So bring up will become x squared. So C is the answer. Because this inverse is wrong. Supposed to become ln x squared. Supposed to become ln x squared. Clear? I'm doing it a bit fast. I know that. Okay, just chasing time a little bit. So that's why. So I really hope that you all can try back these questions here. Okay. You have already given the answers. I will forward to you all in the group that with the question and answers, try to get the question and answer. And if you think you cannot get, you can just message me in the group there also and try to ask lah. So why the answer is like this? Then we can discuss. No problem. Okay, the questions are good. Please do try. And I already set up one more quiz for all of y'all. So please do that also. Okay, so I think I already exit 10 minutes. So yep, I should stop here. I will stop here first and see y'all on Monday lah. Okay, see y'all on Monday. Hopefully everybody okay. Okay then, thank you class. See y'all. Bye.
Thank you, sir.
Okay, please go and try again. Please go and try again. Okay.
Thank you, sir.
Okay. Okay.